Okay, I think we got started. Hello, everyone. You're all very welcome to this ATRF Public Transport Research Committee webinar on integrating micromobility into public transport networks, lessons and innovations. To start, I'd just like to make an acknowledgement of country. So I'd like to acknowledge the traditional owners of the unceded lands which I work and learn and live, which is the Wurundjeri Wurrung people, and I pay respect to the elders past, present, and future. So, as I said, you're all very welcome to today's webinar, which is hosted by the Australasian Transport Research Forum. I'm Páraic Carroll. I'm a lecturer in transport planning at University of Melbourne, and I'll be hosting this session. I'm delighted to be chairing this session on a topic that I'm quite interested in too. I won't be presenting today, but I'm delighted to have three presenters who each provide their own expertise on this topic, which over the past few years we've seen quite a explosion in interest in shared e-scooters, e-bikes, and other lightweight modes, not just as standalone modes of transport, but also as vital links in the broader transport system as first and last mile modes, for example. So today's webinar brings together academic researchers from across Australasia, as well as a researcher from the US, who are currently critically examining this issue and how it evolves from the lens of user behavior, spatial equity, infrastructure, and also planning policy. So we'll hear from Associate Professor Robbie Napper, Dr. Natalia Zuniga, and Dr. Timothy Welch, whose research spans both theory and real-world application. And we'll then have some time at the end for a panel discussion where we'll discuss further some of the questions that you may have. Just before I introduce each of our speakers, I'd just like to mention that there is a Q&A function. I encourage any of you who have questions to pop those into the Q&A box at any point. The speakers will be able to answer those as we go along, and we'll also be able to cover some of those at the very end. And also to remind you that this session is being recorded, so the recorded webinar will be available online after the webinar. So I'd just now like to introduce each of our speakers. So firstly, we'll have Associate Professor Robbie Napper. His presentation, uh, his presentation is titled "Making Micromobility and Public Transport Work in Harmony." And Robbie is an industrial designer, researcher, and associate professor with the Department of Design at Monash University. His aim is to make sustainable transport the easiest choice to make. He pursues this goal by designing innovative vehicles and transport systems, studying a cross-section of the built environment, including bicycles, buses, and road rules, and how people use mobility systems. Second speaker we'll have is Dr. Natalia Zuniga, whose presentation is titled Evaluating e-scooter Integration with Parking Facilities for First to Last Mile Mobility, a Chicago Multimodal Deployment Study. Dr. Natalia Zuniga is a transportation systems scientist specializing in data-driven modeling, simulation, and AI applications for mobility and energy systems. Her work integrates behavioral modeling, agent-based simulation, and energy analysis to study how emerging technologies such as electrification and automation and logistics innovation shape travel behavior and systems performance. She leads multidisciplinary projects across national laboratories, universities, and industry to develop next generation tools for freight operations, intermodal integration, and large-scale transportation modeling. Then finally, we'll have Dr. Tim Welch, who is a senior lecturer in urban planning at the University of Auckland. He specializes in sustainable transportation, equity, and infrastructure planning, recently leading the Suburban Micromobility Hub Network Pilot Program in Glen Eden, which his presentation will be centered on. His work focuses on real-world applications to create more equitable and sustainable cities. Before handing over to Robbie, I'd just like to also mention, for those of you who are not aware of what the Australasian Transport Research Forum is all about, we do have a website dedicated to this, as well as LinkedIn groups. In particular, I'd like to just draw a bit of attention to the Public Transport Research Committee, which is organizing this webinar. So this committee was set up to promote, improve, and enhance quality public transport research in Australasia, and to better focus research on the needs of Australasian public transport applied research. So if you are interested to learn more about that, please do join our LinkedIn groups, and we also have a website for that. So That's all from me, other than just to say that we do have a conference coming up the week after next in the University of Auckland. For those of you who are attending, I'm sure it will be a fantastic conference. And those of you who are not unable to make it, please look out for the conference next year. So that's all from me. I'd like to quickly hand over now to Dr. Robbie Napper, who will be presenting first. So over to you, Robbie. Thank you.
Thanks, Páraic. I'll just get my screen organized and you can give me a thumbs up to make sure that it's all okay.
That looks great.
Thanks very much. Okay, well, hi everyone, and thanks for having me. Today I'm going to talk about making micromobility and public transport work in harmony, which sounds fun and difficult. This is based on some work that I've been doing for a number of years, but most recently work that I did last year with my co-authors Andres, Selby, and Niels. And I'd also like to acknowledge their work in what I'm presenting today, and also some photos in addition by our lab interns, Adrian and Kimia. So hi, for those of you who don't know me, I'm a public transport user and micromobility user as well. And what I'd like to do is take you through some of the moving parts of how we might combine these systems. So for some of you, that might be a reminder. For some of you, it might be new, but I want to sort of unpack the reasons why we might combine micromobility and public transport. Then I'd like to describe some of the working parts. These are two complex systems, and bringing them together is no small feat. So I think we need to have a discussion there. And then I'll end by just looking at a small piece of analysis we did at how we can make them work in harmony, and sort of, I guess, getting into the detailed decision of how and the many ways in which we might make it work. So let's start with the first one. Why are we even having this discussion? I think there's some really simple arguments. And the first one, of course, is that if we look at access modes to public transport, then we can expand those when we change from walking to micromobility. Now, what is micromobility? I think it's anything that's got a nice small human-sized vehicle. So whether that's a sort of one-wheeled skateboardy thing with a motor, whether it's a bicycle, an e-bike, scooters, there's all sorts of things which can fall under this sort of category. But they're all in common in that they are slightly faster than walking. And so when we look at the catchment for a PT map, and whether it's a train or a bus, doesn't really matter, tram, we're familiar with this concept of catchment. You know, how far is a person willing to walk, or usually how much time are they willing to spend walking to a stop? There's various numbers get thrown around, but let's say 800 meters is a good sort of middle ground there. When we look at that catchment expanding for how far you can go in, say, 10 minutes on micromobility versus 10 minutes on foot, it really changes the game. We can have a lot more people accessing the service, which is wonderful. And then it opens the door to maybe, you know, refining some services, maybe having less meandering bus routes and more direct and frequent service. And we know that people love frequency. So the manner in which people get to public transport is deeply of interest here. And I think it's wonderful that if we can expand the catchment and, of course, the let off at the other end. The second beautiful thing that happens when you combine micromobility and public transport is speed. It's remarkable what you can achieve. So if we think about a metro map, or if we think about a large city that's got railways everywhere and trams everywhere and buses everywhere, it's wonderful because you can use your micromobility in accessing that mode, and then you can reap the benefits of that high speed part of the mode. So you can jump on an express train, have a little break if you're using a human powered or a partly human powered vehicle, and get off at the other end, having traveled fast. So just the speed is really lovely. And I think there's also an equity thing in here as well. There's a very large segment of the population who do not have access to cars, or are too young to drive them. So if you're a kid with a scooter and you're 12 years old and you're going to basketball practice, you could actually combine modes, and you can have that speed that your parents might enjoy in their car, but you don't have to own a car to achieve that speed. Whether you beat it or not, it's definitely faster than sort of cruising along at 15 kilometers an hour on your bicycle or on your scooter. So there's some really nice things that happen there, I think. There's a sort of a group of reasons together here: flexibility, space saving, and lower cost. the alternative mode to a lot of these journeys is the car. And the thing about a car is you tend to want to return to it in the same way that you might want to return to your own scooter or your own bicycle. But in the micromobility space, we have a lot more of these shared modes, these vehicles like bicycles and scooters, which can be used by one person and then used by another, which means we can do interesting journeys. We can have open draw trips where we take a train a different way home because we want to stop by a particular shop or pick up the kids from school. So there's a flexibility that we get when we start using vehicles that don't belong to us, which is quite cool. There's also a flexibility around where we choose to park, whether we might bring a vehicle on board with us or not. There's a few decisions that can be sort of changed there depending on what we want to achieve that day with our mobility. It's no surprise that these vehicles, micro-mobility, there's a clue in the name, they're smaller than cars, they save space. That very, very precious space that's highly contested in our urban environments. So the more of that space we can save, the better. And they cost less as well. So the ownership and maintenance of these vehicles is more accessible than a lot of the alternative vehicles that are on the market today. Cars are very expensive to own and operate. Scooters, e-bikes, these sorts of things are lower cost. So it is possible for households to give away, to get rid of one of their cars, or even to go car free or car light in their lifestyle. So there's all these sort of wonderful benefits. That's all well and good, you might say, but aren't there a lot of moving parts? And indeed there are. And so my next part of my brief presentation is to just describe what some of those parts are. And if you've heard me talk before, you'll know that I love the starting point of looking at vehicles. And of course, we're combining stuff, folks. So trams, buses, trains, we've got to think about how these vehicles work and about how they work in our local area. Not every metro train is the same. All sorts of cities all over the world have different bus configurations. Trams, old and new, very different configurations, different things going on. But what we're doing here is we're combining these with other vehicles. We're combining them with things like basic city bikes, like electric scooters. And that's where things get kind of spicy and kind of interesting. We actually need to really think through these characteristics of these vehicles. Some of the electric scooters are quite big these days. Some of them are really small and they fold up and they're smaller than a suitcase, which is amazing. There's also a whole bunch of new micromobility vehicles on the market that can do pretty amazing things, but they're a bit different. So we have bikes like this electric long tail mini velo, which is just a bicycle typology. It can do amazing things. It's electric assist. You can carry 2 children and 50 kilos of groceries if you want to. But if I show up with a bike like that and I want to put it on the front rack of a bus, I'm going to really struggle because that micromobility device actually weighs 60 kilograms. You can't lift it up. So we have to think about how we join these vehicles together. Next one, of course, is ports. What happens at the places of interchange where we get off one vehicle and get on another? Do we just have kind of informal leave bikes and things everywhere, or do we have more structured environments where we're expected to put things in particular locations and we can therefore fit a lot more in? That might be kind of good. Back to that contested space kind of issue as well. Where do we leave them? It's great to have accessible vehicles, but should they really be occupying the footpath? Couldn't we maybe occupy, different spaces, occupy some road space or something like that? So we've got to think about what happens at each of these ports. It can get really tricky, but there are some good solutions out there in the world as well. If you're operating a share scheme, you're going to have a lot of vehicles piling up at your ports. There's going to be a stockpile. So here we have the Dutch OV Fiets bikes, and there's thousands of these at some stations. So they've got to be designed in a way and housed in a way that can be sort of efficiently carried out without damaging the bikes and to make them accessible to end users. And also at ports, different things happen. I was amazed to find here in Delft, at the Delft station, there's a 30-minute parking for bikes and scooters out the front. This is if you're just popping in to top up your card or, buy some frites. So there's this sort of system that has to work at our places of interchange. And typically the space at those places of interchange is really precious. Here's a bike rack that we designed in my lab to put bikes into a car park without digging any holes. We've got to think about the ways as well, the connective tissue. And of course, infrastructure is the big issue with micromobility, how we share the shared paths, how we share the roads. we've got to think about how these vehicles work on the paths that are provided. And here we've got a one-wheel skateboard type thing being used by somebody on a wooden boardwalk, and it's kind of working, but this person was riding quite slowly. So thinking about how we combine the different ways that the riders and the users are actually going to be using on these devices, and also how they're going to be getting through the neighborhood anyway. So there's all sorts of things going on. There's those peak periods that we know so well. We've got people queuing up to cross the road. We've got cars and children on the road together. And then let's add in some micromobility devices to try and get people out of their cars. Well, where do they fit into our urban environment? We've got to have the ways to actually make this mobility possible. Lastly, to the traditional vehicles, ports and ways, of course, we add information. What kind of information is available to our end users? This is really important if we want the system to work. So here I was booking a train ticket from Delft to Utrecht, and I could see that there were more than 1,200 OV feet available at Utrecht Central Station. I could tell that just before I got on board. That's great information. Do we have that? You know, do we actually have a robust sharing system that tells me when they've run out of bikes at the other end and I can come up with something else? Or do I just not know that and I sort of have to take a leap of faith? The information we provide can also provide some behavioral controls. So here's a Fiets card, so a bike ticket. You know, paying money to put my bike on the Dutch National Railways. Or this is my daughter's bike, but the idea that there's a certain time period where that's permissible and it's off peak, but it's still going to cost you, you know, almost 10 euros to do that. We have to have an information flow. The nice thing here is that the railway knows how many people are getting on board with bikes, which is great. So they can judge demand. They can maybe think about that, how it impacts their future rolling stock designs, and maybe how the span of hours for which they allow bicycles on board. And if you think about a station, well, there's a platform or there's a bus stop, and things have to happen there. And the provision of information with micromobility means that we have to tell people if there are preferred carriages for them to get on board, like in our new metro trains here in Melbourne. But even the platform, it's quite a congested space. So it's good if we don't have people walking up and down there with e-bikes and bicycles and scooters. If they know where to go and where to stand, if they're taking their vehicle on board at all, that would be good information to provide. So pulling that all together, vehicles, ports, ways, and information, my message here, or my advice, I suppose, is that this is where we need to worry about the small stuff. You know, it became a sort of catchphrase for people to not sweat the small stuff, but I think sometimes we actually do need to sweat the small stuff if we want a system to work. So thinking about these combinations of the vast array of vehicles, for example, just to take one part of this, is where we really need to think about how will somebody do this? You know, is there a place for them to lock up their e-scooter so they can get on board a bus and not take it with them? We have to sweat that small stuff. The last part of my talk today is just to show you an example of how we sweated the small stuff, I suppose. So we have to have harmony in this system. And to re-emphasize again what I said before, you know, public transport is complicated enough. And micromobility is also fairly complex when we consider people's desires and things. We want to get more people out of their cars and onto small devices. Those are both complex standalone things. And now we're talking about mashing them together. So getting them to work in harmony is really quite tricky. As part of the Victorian government's trial of electric buses, the whole idea of which, of course, is to decarbonise the public transport system and to get emissions down in mobility more generally, we looked at how we might combine bikes and buses, whether that's e-bikes or bikes, doesn't really matter. Now, what we did is we did an artifact review, which is kind of like a literature review, but of things rather than of books and sources. And we found quite a dizzying array of ways that you might combine bike plus bus. So we've built this taxonomy to sort of help decision making. And you can see at the very top that there's a big decision to be made around how you might let people combine these modes, whether you're going to let them take their vehicles on board, and if you are, maybe of what timing you're going to allow, or whether you're going to require people to park their vehicles at the port, at the bus stop, or whatever it is, and then grab a bike share at the other end of their trip. Whether you install secure parking, whether you have hoops, these are all things that need to be sort of thought through. And there are pros and cons to all of these different things, and they all look different. You know, it's just not possible to fit 20 bikes on board a bus unless you do something quite drastic with the design. We found so many different ways of doing this. It was sort of impressive in a way, but also kind of irritating because there's no clear winner. But at least there are worked examples from all around the world for how you might have some of these things working. So my colleague Andres drew this illustration to help sort of guide what that actually looks like. This is a way of summarizing all that information. And what I love about this illustration is that it communicates the various ways quite directly for what this might look like. So if we're going to look at having bike parking and maybe a serious amount of bike parking at bus stops, what are people going to demand? They might demand that that parking is actually secure or undercover. So that can look like the image there on the top left. We found some examples where buses were towing trailers and the trailers were just for bikes. And that's the image on the top right there. So people load their bikes up, and whether that's for regular service or whether that can be for special events, they sort of both work, which is quite interesting. And the idea of putting a bike on board the bus, there's not much room on buses, take it from me. And whether we put the bikes inside on board, that's technically feasible, but sort of socially difficult, or whether we have bike racks on the front or the back of buses, much in the same way as we have contested space on board trams and trains. Those are decisions that need to be made by the local operator. It might sound like a crazy idea to put bikes on board light railways, but Canberra's doing this really well. There's a bike rack, a bike position on board the Canberra light railway. And of course, in Melbourne here, we've seen some bike racks starting to come on the front of buses, which is really useful too. But as I said before, you've got to sweat that really small stuff. You know, how does a person lift their bike? How do they lift their e-bike on board if that's what you're doing? So there's almost too many options, folks, but that's really the message there. Getting them to work in harmony requires us to think about all the tools that we place at the disposal of that rider if we want to get them to make that decision, or if we want to just make their life a little bit easier, more equitable, maybe save them some money, that kind of thing. So that brings me to the end of my section of today's webinar. So thanks so much for listening. I'm going to post a link to this presentation and the paper from last year in the chat as well. I'll leave that link live to this presentation for the remainder of the day for those of you who are watching this today. So at this point, I will stop sharing and I'm happy to pass over to the second speaker, which is Natalia. Over to you, Natalia.
Thank you so much, Ravi. Let me share my screen. Right, I think it's showing. Well, good afternoon, everyone. Thank you so much. I'm very happy to be here presenting a different perspective of the study. The presentation's name is Evaluating Electric Scooter Integration with Parking Facilities for First and Last Mile Mobility. Specifically, is a use case, is a Chicago deployment study. My co-authors here are Jan Zil, who's actually locally located in Australia, and Josh Wald, who's our team manager at Argonne National Laboratory. The main motivation of this specific study, this specific project, was because of the traffic that we see in the city of Chicago. The parking is a big issue in the core downtown of Chicago. So research estimates that 30% of the vehicle in traffic is likely cruising for parking. And this happens a lot when we have aspects such as the core parking is cheaper than the off-street, and people prefer to cruise more, to trying to find this parking, and this generate a lot of congestion, and this can scale up to significant magnitudes. So regularly when we see parking policies, everything is focused on the cost, on trying to put more restrictions, but when there is very little multimodal integration evaluated in this type of policies, while the centrally located garages have this opportunity to help reduce parking, if they work together to provide incentives to compete with car parking. And this can also be useful for foster transit and micromobility use. The big challenge is private sector adoption of these incentives and the collaboration with cities and policymakers to provide this connectivity and these multimodal integration programs. So with that in mind, we have this project in which we're trying to bring the idea of providing providing access to electric scooters to kind of incentivize the use of the centrally located parking so that you don't have to cruise for parking that could generate this traffic, but also can access different places and more of this multimodal integration. And for that, we did this partnership in which we provided the electric scooters for the parking users, and in a specific downtown parking lot, which is actually located, for those who know Chicago, is located below the Bean, the central park area, and is a very strategic location for that purpose. The initial fleet consisted of 8 electric scooters, and then was expanded 16 in a later part of the project. And initially, the electric scooters were provided specifically for the parking users for free. This multimodal integration can provide with valuable information, mainly focus on how cities and parking managers could work together to provide this connectivity. So in this presentation and this specific study, the main contributions are divided in 3 sections. So first, it's an overview of the pilot program, and as an example of how can this partnership be done. And then we also use this the data to provide an analysis in terms of how were these electric scooters being used, and how is this which the coverage area that they were providing. And then finally, we did a small market potential analysis using Chicago Household Travel Survey and an agent-based simulation for routing comparison, in which we mainly wanted to understand what would be the maximum potential of the market of this specific electric scooter option. This is an example of how the electric scooters were actually located in the exit of the parking lot. So the program aimed to set a precedent for integrating micromobility with traditional parking infrastructure, and included partners such as Civic Infrastructure Collaborative, Argonne National Laboratory, Millennium Parking Garage, which is the main owner of the parking I mentioned, and Ridy, which was the electric scooter provider. We advertised the program through direct email, through the Millennium Park Garage website, in Get a Garage signage, and different parking platforms such as Spot Hero and Páraic. I think one of the main roadblocks that we had was this getting to the users to understand the program, to kind of use it initially. And the users can start using the electric scooter by completing a very brief sign-in form and downloading the cell phone application and setting an account. This also allows us to have an option of asking more information about socioeconomic and demographics aspects of the users. And one of the limitations, of course, is that it was just restricted to this specific garage, but the idea is to provide example of application to how can this be extended to other garages across the city. The main objective of this pilot study was to foster this multimodal integration, integrate the electric scooter with the existing transport and the parking network, and enhance this travel convenience for parking customers. The electric scooters were strategically placed in docks with clear signage and wayfinding aids, and we provide this partnership with Spot Hero and Páraic, which are platforms for parking providers, and for advertising this. And the main kind of goal was to try to scale this adoption, to analyze how replicable is this model to attract private sector interest and demonstrate that success, and encourage that scalability across different urban centers, not only Chicago, but in other areas. A few highlights of the first part of the pilot program. We found the highest demand peaks are weekdays 7 a.m. and 6 p.m., which are actually commute times. And for the first part of the program, there were more than 1,000 trips and in terms of a year. This is the first fleet, which is only 8 electric scooters at the beginning. We got almost the full electric scooters occupied almost all the time. These are the most frequent times that we saw. And some highlights about the users that we found. They tend to be young and highly educated with stable, high-paid jobs, and their household income is higher than the regional average. And nearly half of the users didn't have experience with electric scooters in the past, which is interesting. They were able to still adapt to the program. They own 1 or 2 vehicles, and the majority own bikes. And we went more deep into the data. Now that we have access to what the users were doing into the city, we wanted to try to understand how helpful and how useful was the project for in terms of behavioral and what they were doing. So we kind of did a specific first test in trying to catch what were the stops that they were making and what were they mainly doing. So we did classify and detect some of the stop with the trajectory that we obtained. The star here represent the parking location, and then we kind of spreaded the stops across the city to see what they were doing. And with information of the trip characteristics, we kind of did a short analysis on understanding what they were doing. So we mainly found that the service expanded the coverage area for parking users. The average trip distance was about 1.2 kilometers with maximum of 8 kilometers. And we found very cluster areas of work within the core of the city, specifically entertainment across the major touristic attractions, or some other of the trip purposes spread across the city. But the thing that we found the most interesting is how this program who can help reduce the need for search for parking in near destination, as it increases the accessibility and the catchment area that was discussed in the previous presentation, in which usually users are mainly willing to walk only a quarter of a mile or 400 meters. But with the access to electric scooters, they were able to access locations that were even further away. Were they using only their vehicles, they must have been funding for parking in those specific areas and doing other aspects for that. But now we provided a specific mode in which they're more flexible to access different locations in the city. With that in mind, we did a very small study on trying to understand how big is the market, the potential market for developing this more of a large scale model for electric scooters. So we basically analyzed the area in which the electric scooters were operating in the city, and we recreate daily tours using the household travel survey and our agent-based simulation, which basically with a sample of the population, we know what they do across the day. So what we were trying to do is recreate all tours of the city of the people who were in a day were doing some similar pattern of trips. And we found that nearly 97,000 tours per day could be replicated within this model, in which they could park here and reach their area. Of course, this is the maximum potential achieved if all users travel switch to electric scooters. And when we go a little bit more in deep into the user characteristics and all these aspects, we found that the potential demand adjusted could be in a range of 5,000 users for the whole city in a day. And this could help us kind of have an idea of how can we scale this up. And this help supports parking managers planning for future program expansions. We found that this pilot program could inform opportunities for improving mobility and connectivity in this dense urban area. And it provides collaboration opportunities with privately owned programs that enable the partnership with cities, researchers, and policymakers, and overall enhance the urban mobility with a reduction of congestion. It helps us to provide some research insight. The data on the electric scooters, it's very helpful to kind of understand the user behavior, the travel patterns, and adopter profiles to be able to transfer these to other areas, and also provide opportunities for parking management applications. And it is a good strategy to boost multimodal mobility in the city. With that, just want to summarize this pilot study offer a promising solution for improving urban mobility, reduce the congestion, and support mobility improvement goals. We examined this first mile, last mile solution to parking cruising in downtown area, and include some aspects of user behavior, trip data, and market potential. The program impact is more of on the side of promoting alternative mobility, integrated solutions, and high customer adoption. We demonstrated a strong demand and successful during the pilot metrics. And for future work, we're working on quantifying broader regional benefits. What would happen in simulation if we have this program in other cities, in other parkings, more of a large scale. But also there's multiple other economic and health benefits. With that, I pass over to the next presenter.
I think you're on mute, Tim.
All right, I was just talking to myself. That's okay. Yeah. Okay, so I'll go fairly quickly through this. This is a project that started a couple years ago. It was funded by the National Transport Agency here in New Zealand, NZTA, under a program, unfortunately, that's no longer running, but an innovation fund, which offered really anybody an opportunity to put together a research project, generally applied or something, testing something on the ground, but that was fairly free to be successful or even unsuccessful and share the learnings from that process. It's an unusual way of funding projects. We threw our hat in the ring here and developed what's called the Gleneagton Micromobility Hub, which is the idea that we could maybe bridge some of the first and last mile gaps to public transport in a fairly suburban neighborhood, an area that doesn't have good infrastructure for micromobility, has lower income households, has a higher proportion of Maori and other minority populations. And then to do a lot of testing to see how uptake might happen. This is done on the idea that active access to transit is really important for health. It's important for access, so it provides more opportunities for people who are even farther away from public transport, especially micromobility, to connect to those transport hubs. And then obviously there's some climate impact there as well. We tried to study metrics across many of these different measures or outcomes. Kind of our pitch for this came from the idea, and Robbie sort of mentioned it a little bit earlier, is the idea of a catchment. And so in Glen Eden, And for many other neighborhoods in Auckland, what we find is that if you just look at a traditional catchment that is kind of uncongested driving, it typically gets you the highest range, highest catchment. But not far behind that is e-bikes and e-scooters and cycling and walking to some extent. But these active modes actually have really good catchments and travel times. If you consider congested driving, and this is a catchment measured under actual driving conditions on peak hour, that catchment for driving drops significantly, and suddenly you're looking at as active modes or micromobility modes have a much larger catchment, a much faster travel time. But yet we still see cars dominating ends of both trips across Auckland. Part of the reason we see this is, and this is images from Glen Eden, is really poor connectivity and poor infrastructure connecting to stations across neighborhoods. So this is what where our future hub would be. Eventually, there's kind of one bike staple with one bike. We like to say that this entire hub was planned for the one person here that year after year brought their bike over. So we were happy as long as they adopted the hub. We called that a rate. And if someone else did, that's 100% increase in cycling to this station. So the first last mile gaps kind of create this car dependency. We see that over and over. This is old. It's in the literature. It's nothing new in that sense. There's high cost to transportation, right? Whether you're owning the micromobility or you're owning a car, it's expensive all around, and public transportation is becoming more expensive as well. Lots of safety concerns. The environment, especially in Glen Eden, was set up to prioritize cars, and everything else seems like a bit of an afterthought. So people just avoid it because not only is it not available, it just doesn't feel safe. We don't have, there's a lack of lighting, there's no secure bike parking. And so it's just not something, we roll out the red carpet for cars. We don't do that so much for other modes. So we decided to beg, borrow, and eventually steal 3 car parks at the station. It was a long endeavor. This was a project that was going to span essentially 14 weeks to set up and 6 months of study. It took us a year to get all the permits to actually put these infrastructure in. And so because the car parks were considered road infrastructure, and that's very onerous to put something down right on the road. Eventually, we got it with some high-level help, cutting a few some red tape along the way, and a lot of learning. But we basically eventually dropped 2 20-foot containers at the station, and have developed some smaller hubs along the way in the neighborhood to kind of help bridge that first last mile gap as well. So this is the station before the hub. And then this is after the hub, the infrastructure we built. The container, the big pink container, secure e-bike parking and charging, and a giant wayfinding sign there, community messaging and maps. And then the other container is a maintenance and distribution facility for rental shared scooters and e-bikes. The shared scooters and e-bikes were also tested because there were no shared scooter companies operating in this neighborhood or even close to this neighborhood at the time. So part of it was us encouraging companies to come into the neighborhood and operate. But we kind of were operating under initially that if you build it, they will come. But we got nervous that maybe if you build it in a place where it's never been built before, they might not come. So we decided to start to develop a community engagement and community centering program. We engaged a local muralist who did workshops in schools he painted a mural on the side of one of the containers. They painted murals in the schools, similar murals. They kind of designed their own. We painted initials of each school onto the container to provide ownership for the kids. who would then bring it back to their families and say, look at this, we've got this hub. We did in conjunction with Auckland Transport Agency here, learn to ride activities around the hub and in nearby parks, to kind of introduce the idea of micromobility and the use of public transport in the neighborhood. And a lot of this was all subsidized by local community grants as well, in addition to the grant we got from the National Transport Agency. We also conducted before and after studies in the community to see if attitudes towards public transportation, attitudes towards micromobility, and attitudes towards the combination of the two had changed. I'll get to that in a second. We also measured changes in use of public transport. This is not causal relationships, but they are correlated. So we saw increases over a period of during the program, which lasted for 6 months, growth in both bus and train usage, and growth in excess of the change we saw around the rest of the system. We measured change not just over time and compared to previous similar periods, but change compared to how the rest of the network performed. Again, this is more correlative than causal, but it was a good indication. So we had, just in a short period of time, this wasn't the full period, but over 300 bikes parked at the station, over almost 1,000 e-scooter trips. And so an 8x increase in kind of the usage of the Gleneaglen rail station in as a whole. Again, that 330 bikes might not sound like a lot. The in before was 1. So we thought it was pretty significant. This is a lot, so I'll just quickly go through it. We also did CO2 mitigation impact modeling from the data we collected, and kind of the value of a hub like this in terms of New Zealand's carbon credit scheme. And essentially what we find is it benefits in terms of CO2 around $36 per e-scooter. And then this doesn't go down into the bike level, but again, significant savings and potential savings in CO2 equivalents across mode shift and growth in both bus and train use, and reduction in the use of the park and rides. Some of the stuff we learned over time is that really you can't just plant infrastructure. It's really got to be kind of community sensitive. So we saw changes in the use of public transportation across. I may have dropped that slide. Between gender and age and home ownership, all of that affected adoption of micromobility and willingness to use it. We saw the significant growth in the use of micromobility and the willingness to use micromobility to use public transportation, and the number of trips individuals took before and after the hub was in place. We know that integration is really important, so it needs to really connect seamlessly. This was our first test run, but what we want to do is reduce the barrier between using that micromobility and accessing public transportation. This was 6 months. So what we need is a more longitudinal study. So we're working on how we can measure that over a longer period of time. We're really encouraged that 6 months showed us statistically significant results in terms of change behavior. But again, that's a fairly short window to really look at changes in user behavior. We also know that there are significant differences in gender gaps. So women typically feel less safe using micromobility as a way to access public transportation and to move around public transportation stations. We designed our hub with extra lighting and cameras to help alleviate some of that concern, but we know that it needs to go farther in order to target groups that are traditionally hesitant or less likely to adopt these modes as well. So we know that micromobility is a good tool to break down. It can be used as a tool to kind of break down the barriers between community use of public transportation and essentially the alternative of riding. But again, we really feel that it's a community centering, a community engagement that needs to also take place, which often doesn't happen. We often stop at the infrastructure development. We're working towards an expansion of the hubs network across Auckland to see if we can grow the footprint there and grow ridership. Again, more demographic specific programs to bring in a larger proportion of the population that may not always use these modes, and strengthen our community partnerships. There's a lot of agencies that work in a kind of a siloed environment that we can work with to create a more holistic micromobility program. And again, back to what we really want to do is have longer term research and figure out how micromobility can be better integrated in the community, better used to enhance public transport. Really, we just need time to do that. It's a really new mode, and deep studies into this are still fairly limited. That's one of the keys we need. That's the micromobility hub. And so as we go, we're trying to expand this program, encouraged by very small budget of the initial pilot program. Good for me.
Great. Thank you very much, Tim. And thank you very much to Robbie and Natalia as well. Three great presentations, each providing different perspectives on this topic, I think, which is quite nice to see different ways of examining it. We have had some activity in the Q&A, and thank you for the panelists for answering those questions. I don't know if any of you'd like to elaborate on some of those responses in particular, but we might take a couple of them before addressing some other questions. So I see one that's come up in relation to banning electric bikes on board public transport services in Sydney. Us Victoria are considering doing the same, of course. Do any of you have any particular views on this topic in terms of, the potential safety issues or not, whether this is something we can overcome, or if it is, a valid reason for, banning them. I don't know, Robbie, do you want to elaborate maybe on what you've said already, and then we cover someone else?
Yeah, sure. I actually thought this question would come up today. I think it's not a mobility issue. I think it's a battery regulation issue. To me, it's sad when the can gets kicked down the road. There's so much great stuff that we can do when we combine modes, and I think it's easy to pick on the new mode. As humans and in society, we've been picking on the new mode ever since there's been new modes. When the bicycle first came along, it was going to scare the horses. Then when the mopeds arrived after World War II, they were going to scare the bicycle riders, and it's always been a thing. So we have to have better ways of planning for these modes. And I think it's easy to just point the finger. So I feel like at the moment, the cultural moment that's occurring is actually we're using batteries as a way to pick on this new mode. And I just wish we had better battery regulation, because we're not going to ban people from bringing their power tools or their mobile phones on the train, are we?
Natalia, I mean, from the US perspective, have there been similar, policies or regulations being made to ban the carriage of these devices on public transport services, or how is it in Chicago?
Well, in every state, every transit agency works independently, but in Chicago, it's not something that is prohibited. It's not. Actually, it's more like encouraged for users to
Okay,
integrate.
interesting. How about in New Zealand, Tim?
I mean, we have a strange relationship with any kind of micromobility bikes or scooters and buses in New Zealand. So our buses, except for a new pilot program starting now, none of our buses are allowed bikes at all. Scooters are more of kind of Wild West. You can't take it not. And for us, that's why kind of the hub was important as well, is you can kind of bridge that gap and leave something securely. I forgot to mention we had secure scooter parking as part of that hub as well. It wasn't as well utilized as the bikes, but certainly we're in a difficult position where people are still skeptical about scooters as the mode.
Mhm. Okay, great. Thank you very much. I see some new questions have come in. One from Graham Curry. So why don't we have integrated ticketing for micromobility and public transport? Even Netherlands doesn't seem to have it. Anybody have any views on that?
I can say that we do for the bike parking. We were able to use uh, your same hop card here, as you could to open the bike parking and unlock it. You could get on public transit. Now we've opened the public transportation up to any payment mode, whether it's your smartphone or credit card. So now they're less app dependent, because they also work on, that's how our systems work here. But that integration and payment method are a big barrier that we still need to address better.
Right. Another question comes.
I'll add to that if I can. That Graham's asked about what the Netherlands doesn't seem to have, and I think what's happening in the Dutch system is that there's a very strategic set of actions there is to guide or to nudge people's behaviour. So with the OV chip card, you can park your bike, and if payment is due, if you park your bike for more than 3 days, you tap out with your card and it deducts the payment there. So there's an integration there, and there's also an integration if you have if you're a Dutch resident, you can get access to the OB feeds. So there's an integration there. But if you just want to do the old-fashioned thing and take your bike on the train, you are subject to a number of inconveniences and costs. And I think that's intentional because bikes do take up a fair bit of space on those trains. And we are talking, in the Dutch example, we're talking mainly about bikes rather than smaller devices like scooters and that kind of thing.
Yeah. I think there's another question there for you, Robbie. From Tefera. How does the integration of micromobility solutions into public transport affect road user safety?
In many ways, I suppose is the short answer. I can think of a good example, though. If you are one of those people loading a bike onto the front of a bus, you're actually standing in the road space to do that. So this is a great sort of point where, sweating the small stuff really matters. We have to think about how we design bus stops, and are they on busy intersections where that space is difficult. Bus drivers, I don't think universally love the bike rack on the front because obviously it's going to interfere with their on-time running, and that's one of their major performance sort of their job. But it is nice that the bus driver can see you loading your bike on there, and I try and give them a friendly wave and hey, we're all in this together kind of thing. And I feel at least sort of somewhat protected because the bus driver is such a professional driver. I think in general, of course, the road safety thing is great to bring up because when we talk about micromobility, we're talking about the strength of the ways and whether we've got bike paths that can be also used by scooter riders or whether we have to put them on shared streets at 60 kilometers an hour. That's a really big road safety issue. And it's another reason why we should have lower speed limits. What's good for micromobility is good for public transport and vice versa, I think.
Question here from Gideon. So I want to know if these models can be applied to streamline transport services and activities in any agricultural economy. That's an interesting concept. Yeah, so I don't know, Natalia, do you have any thoughts on that one? I know it's a bit different to what you presented on, but more broadly on this topic.
I'm not very familiar with what agricultural economy would imply in terms of modes, maybe.
Yeah, I think Gideon is applying that from, maybe his experience from Ghana in an African context. I don't know, maybe Gideon, if you could elaborate on what you mean by that. But I mean, maybe more broadly, how replicable is the model that has been in operation in your example in Chicago? Would that be replicable to other cities in the US, or has it been rolled out, scaled up to other cities?
Well, that is the main idea. We want to be scaled up to this was first example of one garage, moving on to other garages across the city to integrate more of the regional part, and then other parts of the city, other cities that have similar issues and similar opportunities for that. That would be that's the main goal.
Okay. We are almost at a time. I've one or two questions that I'd like just to ask each of you. So, what, I mean, it's quite a broad question, but what would really needs to happen, the shift at the institutional level? So, I mean, are we seeing more integration or co-location when it comes to bringing micromobility and public transport together? Do we need to approach this from a governance or is this a service model perspective? I mean, based on each of your presentations, I think it's interesting in terms of how you examine the topic from different perspectives. But more broadly, is it a governance issue or is it a service issue or both? Where do you see the main challenge being to make this more widespread, particularly in our suburban areas where that first or last mile may be a bigger issue and hasn't, to my understanding, hasn't really been solved as of yet in many Australasian cities. Do any of you want to take that one?
I can give brief perspective of our
Sure.
experience, and I think it's very important the integration of all the parts. So we found that the scooter provider, the city itself, the private, and in our case, parking garages, but integrated with the transit agencies, everything it is needed to have a like working together aspect of it, because otherwise it's going to be disconnected. And one of the great also important part is integrate all aspects of like research perspective as well, as we're trying to do in that pilot program. But it's basically, I do think it's more of an integral part that needs to be cross collaboration of all the parts.
Thank you. Tim, did you want to come in on that one as well?
Sure. Yeah, I mean, it's kind of a chicken or egg argument here. Is a lot of suburban councils and governments that oversee those locations kind of say, well, yeah, nobody expressed in micromobility, so we're not going to plan for it. We're not going to build the infrastructure. Then there's no infrastructure for it, and nobody uses the mode. So really, I think it's an infrastructure first approach. For us, we need to save infrastructure. We aren't going to induce people into mode change or using this infrastructure or these modes unless they feel safe doing it, and they feel safe doing it every day. So that's where it has to come from first. And once the infrastructure is in place, I think we have to adopt the policies and expand how we value these modes as an alternative. We're kind of stuck at this spot where we just don't have the infrastructure.
Yeah. Do you have a differing view, Robbie, or would you agree?
I would agree. I think that we need to set these types of mobility systems on a positive spiral, so that we can build one thing on another. Mobility systems are so complex. So, it's really fashionable at the moment to complain about infrastructure, and infrastructure is a limitation. I totally get that. But it's not much good building a bike path if 2/3 of Australians think that bike riding is just not for them culturally. So there's a cultural part to it as much as there is making sure that people have a working scooter or a working bicycle available to them too. So that's why I always fall back to that vehicles, pathways information, because if any of those parts are missing, you actually don't have a functional mobility system, and you're wishing rather than planning, which is a very different exercise.
Absolutely, yeah. We are unfortunately out of time now, so we might try to wrap it up now. But I'd just like to thank again our three speakers, Robbie Napper, Natalia Zuniga, and Timothy Welch. We probably could go a lot longer, but I think this is a good initial conversation. I think there's still a lot to happen across Australasia in terms of what we can do to better integrate these two modes, or the modes, into public transport networks. But yeah, thank you again for your insights and your findings that you've presented, and thank you everyone for attending. As I said, this has been recorded, so you'll be able to watch it back online when we post it. So thank you very much wherever you are, and have a nice afternoon or evening.
Thank you.
Bye-bye.
Thank you.
Bye-bye.